Assalamualaikum warahmatullahi ta'ala wabarakatuh. So for today, I will present about soil engineering laboratory mini project for subject code ECG263. First, let me introduce myself. My name is Muhammad Muhaimin bin Mukhlis. Matrix number 2021818046. Okay, so as an introduction, the substantial background is a must to address. In this project, the main aim is to determine the plastic and liquid limit of the soil and the particle density. Both are important. It can help us determine many engineering things such as the shear strength, soil stability, slope durability, and many more. For the objective, is to analyze and recommend soil stabilization methods to improve soil stability, increase shear strength, and enhance the engineering properties of the soil for construction purposes. This includes studying case examples, examining engineering challenges, selecting appropriate techniques, and discussing their effectiveness and limitation in different geotechnical situations. Recommendation will be based on literature review, laboratory testing, cost analysis, and consideration of factors such as soil type, site-specific characteristic, construction schedules, and environmental impact. Now, we talk about background of study. For the background of study, we can list two types of soil, which is disturbed soil and undisturbed soil. For disturbed soil, it is referring to soil that has been changed or disturbed from its natural condition in some way. Our engineering projects may be affected by changes in the physical qualities and properties of disturbed soil. There are a lot of causes on how the soil can become into disturbed soil. First, the compaction process. It is common practice to compact soil to enhance its engineering capabilities. It entails exerting mechanical pressure on a soil to make it denser and less compressible. Second, the soil is already being mixed by other materials. In some circumstances, soil may be combined with other substances to change its qualities. While for undisturbed soil, it is referring to soil samples that are obtained and stored in a way that preserve their original composition, structure, and characteristics. These samples are taken without significantly disrupting or changing the in situ condition of the soil. Using specialized methods like soil coring, thin walled tube sampling, and Shelby tube sampling of undisturbed soil are taken. So for the methodology, I prepare two types of tests, which is particle density test and cone penetration test, and I will explain all about it for both of the tests. So we move on to the particle density test. Now we look the apparatus first. The apparatus for particle density test is density bottle, wash bottle, de-air distill bottle, alcohol, either balance, vacuum sets, and constant temperature water bath. So now we look at the procedure. First is to clean and dry the density bottle and the stopper, and then record the mass and label it as M1. Weight the dry bottle with stopper and record the mass. Take about 10 to 20 gram of oven dry soil sample cooled in desiccator. Pour it carefully into the density bottle. Weight the bottle with soil stopper. Record the mass and label it as M2. Pour about 10 millimeter the air distilled water in the bottle to soak the soil. Leave it for a period of 2 to 10 hours. 5. Pour some more distilled water to make the bottle half full. Remove the entrapped air by applying particle volume. Vacuum. 6. Pour some more distilled water into the bottle and fill it completely without any entrapped bubble. And then put the stopper on. 7. Keep the bottle from the Keep the bottle on the stand in constant temperature water bath for 1 hour. 8. Take out the bottle from water bath, wipe it clean and dry from outside. 9. Weight the water filled with water and soil sample with stopper. Record the mass and this time we label it as M3. 10. Empty the bottle and clean it properly. Fill the bottle entirely with distilled water. Make sure they are not entrapped by a bubble or otherwise the partial vacuum has to be used. 11. Put on the stopper and wipe the bottle dry from outside. Now wait and record the mass and label it as N4. Again, empty the bottle and dry it up properly. And the last step is repeat the steps 2 to 11 for two observations to obtain an average GS of the sample. So GS is specific gravity. So this is the actual photo when we proceeding the test. So this is when we weighing the soil sample. This is when we weighing the density bottle with its stopper. Also the same, but this time there is water in it. It's with some dirt. And then there is when we almost proceeding to the next step, which is to vacuum the sample. All this will lead us to the data, and all the data from the particular city test that we make, I have table it. So this is what we get. We managed to obtain mass of dry soil used, mass of water to fill, and also with some specific calculation, we receive the particular density of soil, average particularity, specific gravity, and character specific gravity. So the goals for this test is to determine the specific gravity. So with three samples, we gain three different specific gravity, which is for sample 1, 2.616, sample 2, 1.005, and sample 3 is 2.672. That's all for the density, particle density test. We move on to the cone penetration test. First, we talk about the apparatus. Cone penetrometer, stopwatch, seen in the cup, 0.425 mm sieve, glass plate, spatula and palette knives, straight edge, moisture can, wash bottle containing distilled water, weighing balance, drying oven. Procedure. First, take a sample of the soil of sufficient size to give a test specimen weight at least 300 grams which pass the 0.425 mm test sieve. Second, transfer the soil to a flat glass plate, add distilled water and mix thoroughly with two palette knife. The mass becomes a thick homogeneous paste. 3. If necessary, add more distilled water so that the first cone penetration reading is about 15 millimeters. 4. Push a portion of the mixed soil into the cylinder cup with palette knife, taking care not to trap air. 5. Strike off excess soil with the straight edge to give a smooth level surface. 8. With the penetration cone locked in the raised position, lower the supporting assembling so that the tip of cone just touches the surface soil. 7. Lower the stem of the dial gauge to contact the cone shaft and record the reading of the dial gauge to the nearest 0.1 mm. 8. Release the cone a period of 5 if the apparatus is not fitted with an automatic release locking device. 9. Record the difference between the beginning and end of the drop cone penetration. 10. Lift out the cone and clean it. 11. Take another two penetration reading at different spot. Make sure the difference between first and second penetration reading is less than 0.5 mm. 12. Take a moisture content. And the last step is repeat step 2 to 12 at least 2 more times. So this is the video when doing the test.
Okay, cik. 110. Baik, kita set up. Kita nak.
So this is the data for the cone penetration test result. As you can see, we managed to receive the water content, which is for the sample 1, 15.6, and then 16.63, then 19.05. This is for the plastic limit, and we gain the average water content is 18.9. This is the graph for liquid limit from the cone penetration method, and this you can see the red line, that is the line. For the discussion, particle density testing and cone penetration tests are crucial for assessing the engineering property of soil. Particle density tests determine the mass of solid particles in a given volume of soil, aiding in evaluating compaction, porosity, and load-bearing capacity. Cone penetration test determines soil shear strength, stability, and groundwater condition. Providing important data for engineering design, precautions must be taken during laboratory session to prevent errors and ensure safety. Adhering to safety protocols and following instructions are essential to avoid mistakes and potential injuries. Conclusion. In conclusion, conducting tests such as particle density and penetration tests are crucial before undertaking engineering tasks. However, certain problems can arise. For particle density testing, air voids can affect the accuracy of measurement, but they can be addressed by gently removing air voids after compaction. Human error is another problem which can be reduced through proper training and adherence to standardized in procedure. In penetration testing, problems may arise from excessive water or inadequate sample representation. Minimize this problem is essential to ensure reliable results. For the last is my point of view about this mini project. So the first is the exposure. The exposure on how to use the soil apparatus. As a future engineer, it is a relief when we learn more about the apparatus so we can use it in the future as a future engineering. Second, bounding among groupmates. In an actual engineering laboratory situation, the communication between groupmates is crucial and it will create a boundness. In laboratory, you will not work alone. You will work with your group. So, with this mini project, we learn to make the group mate together, bounding together, so the test can be run smoothly. Third, practical application. This hand-on experience can help to understand more about the properties and method. And the last one is equipment familiarities. With the equipment familiarities, it is easier for us to conduct it at the future. That's all for me. Thank you.